Okay, hi everyone. So I think we're going to get started. So yeah, look, thank you everyone for joining the webinar today. Just so you know, if you do have any questions throughout, you can use the tab on the right-hand side. Just input your questions there and we'll get to them at the end during our live Q&A. We will also be sending on the webinar recording and the slides after, so you'll have that for future reference. So just very quickly about myself, my name is Fionnán Motherway. I'm a product specialist here at Fivetran in our Dublin EMEA office. So yeah, welcome everyone. And yeah, just a little bit about Snowflake and Fivetran. So Fivetran and Snowflake have a very close partnership, close alignment for a number of years now. Both tools were built natively in the cloud. Both tools built on a philosophy of a modern data stack, sort of best-in-class cloud migration. And this is sort of borne out as we have now over 240 mutual customers, some big names there, Deliveroo, BCG, Urban Outfitters, and a few more. And yeah, I think a testament to our great partnership was Fivetran winning the 2019 Snowflake Tech Partner of the Year. So I think this really was a testament to a lot of hard work, a really great fruitful partnership, but most of all, a lot of mutually happy customers. And so yeah, just in terms of introductions, who we have with us today. So we have Barry Tallon. Barry's our sales engineer here in our Dublin EMEA office. And we also have Peter Jensens, who's a senior sales engineer at Snowflake. And in terms, we'll just go through the agenda. So today we're going to have, Barry is going to speak to us about what is Fivetran, how to load data into Snowflake using Fivetran, and then go through some transformations that you can do in Snowflake with the Fivetran Transformations tool. And then we'll have Peter speak a little bit more about Snowflake, the technology and architecture of Snowflake, and then how to leverage data in Snowflake. And then finally, we'll finish up with our live Q&A. So again, if you have any questions, just type them in and we'll get to them at the end. Yeah, perfect. So Barry, I'm going to pass on to you. You can take it from here.
Thank you, Fionn. Thanks for the introduction. Yes, as Fionn said, I'm a sales engineer here at Fivetran in the Dublin EMEA office. I'm going to talk today about what is Fivetran. I'm going to show you a demonstration about loading data into Snowflake using Fivetran, and then I'm going to show you some quick transformation examples. So first off, what is Fivetran? Here at Fivetran, we are enabling our customers to centralize all of their different data sets and data sources into a central location. So what that really means is we're offering data pipelines as a service, which enables our customers to replicate all of their data into a Snowflake instance in the cloud. As I said, it's a fully managed data pipeline as a service. There's no configuration and no maintenance on the end user side. There's also no coding involved on the end user side. We have over 150 out-of-the-box connectors that will replicate your data into a ready-to-query schema in Snowflake. There's a 5-minute setup for all of these connectors, and we also offer 24/7 support. We are SOC 2 Type 2 compliant, as well as GDPR and PCI compliant. Your data is encrypted from end to end, both in transit and at rest. And once your data has been synced into your central warehouse, we immediately delete it from our servers, so there's no data retention whatsoever. A lot of you might be familiar with the diagram on the left here. This is the traditional approach that businesses have been taking in terms of their data stack, data analytics and business intelligence. A lot of this would have been performed in-house on-premise data warehouses, where you would have your engineers extracting the data from multiple different data sources. You'd be performing some transformations on that data to strip out the data you need, to cleanse the data, and then load it into your warehouse for visualization and analysis. But what we're doing here at Fivetran is we're disrupting that classical ETL model and calling it ELT, or the modern data stack. What that means is we're ingesting all of your data from each of the different data sources and loading it straight into your data warehouse, where you can then perform your transformation transformations directly in the warehouse for analysis and reporting. It's very simple to set up, as I alluded to earlier on. You simply authenticate your data source and then let Fivetran do the rest. Here you can see just examples of the different types of data that we can pull from. So cloud applications, we can pull from many flavors of databases, both on-premise and in the cloud. We can pull from file storage locations, and we can also pull event and webhook data. And what happens is you'll initially authenticate your data source with Fivetran, and we'll start pulling all of the historical data and loading that into your warehouse. We perform some light data cleansing, some light normalization, and we standardize the data types across the board so that your data is ready to query once it lands in your warehouse. And once the historical sync is complete, we then start doing the batch updates or the new or changed data into your warehouse. So I'm just going to give a quick demonstration of how to load data into Snowflake using Fivetran. So here I am here in the Snowflake, in my Snowflake instance. You can see all our databases at the side. You can see there's a Partner Connect button here up on the top right-hand corner, which I'm going to click, which will redirect us to the Snowflake partner page. Now, users will need to have account admin privileges in order to perform this task. So I'll click on Partner Connect, and you can see Fivetran here. So what I'll do is I'll click Fivetran, and we're just being given a warning here to say that Snowflake is going to create a Fivetran database with a Fivetran warehouse. We're going to create a Fivetran user and a Fivetran role with all the relevant permissions that we need in order to sync that data into your Snowflake database. So if I click Connect here, it should activate my account. Yeah, my partner account has been created and it's ready to be activated. So if I click Activate, it will redirect me to a new trial page where I can enter a new password and begin my Fivetran trial. Now, for the purposes of this demonstration, I'm not going to start the free trial. I just have I have a warehouse created already, and this is the Fivetran homepage once you log in for the first time. You can see on the left-hand side here, we have a menu, so you can see all the connectors you've added. We have a transformation section where you can add transformations. We have a manual upload function. You can see the warehouse tab here is our warehouse that we've connected through Snowflake Partner Connect. We have a logs tab where you can connect a logging service like Stackdriver or Amazon CloudWatch. There's also a users tab where you can configure users and grant permissions and roles. And we also have an alerts feature for any issues that might happen with any of your syncs, and a notifications page as well. So I'm just going to add a new connector. I'm going to set up a MySQL database that I have running in Google Cloud Platform. So what I'll do is just click Add Connector. You can see all the different tabs here, the different types of data sources we can sync from. So we have applications, databases. I'm going to scroll down to Google Cloud MySQL and select that. Oh, sorry about that. I must have been logged out. Let me 1 second. I'll just log back in. Oh, apologies about that. So I'll just click Add Connector. I'm going to search for MySQL and select Google Cloud MySQL. So this is the new connector setup page. So I'm going to give my my connector a unique schema for the warehouse, so it makes it easier to define where this data has come from once it lands in your warehouse. So I'm just going to give it Google Cloud MySQL test, let's say. I'm going to enter the IP address for my database. I'm going to select the default port of 3306. I have already created a user in our database called Webinar with the relevant permissions. I'm just going to click this link, configuration instructions, which will redirect us to our documentation page, which will outline the steps that you need to take to configure your MySQL instance, and also the relevant permissions that you need to grant to the Fivetran user. I have already pre-created this user. So I'm just going to enter in the password. And you can see here for connection method, we can connect both directly, and for the more security conscious customers, we can connect via an SSH tunnel or a reverse SSH tunnel if necessary. We're going to connect directly to this source for this demo. And I'm just going to click on save and test. You'll see on the right hand side, we'll start performing some tests to see if we can successfully connect to the host. We're going to validate the certificate. We're going to make sure we can connect as the database user and have the right permissions and make sure the database has the right configuration set up for us. I'm just going to go ahead and accept this certificate. I'll just give this a second more. Okay, all our checks have passed. So that's brilliant. I'm going to click on View Connector, and this will take us to the connector homepage. So when you initially collect your source for the first time, it's going to start in a paused state, so you can do some additional configuration, and then you can unpause the connector and it will start syncing. So I'm just going to click OK. You can see this is the schema tab. So there are two schemas in this database here. I'm going to deselect the sys schema because I don't want to sync that data over. Now you can see all the tables that we're going to sync with this connector. What you can do is deselect tables that you don't want to sync over. You can also make use of our column blocking feature, where you can deselect columns that you don't want to sync, and also our column hashing function, which will hash the data so that it's still queryable in the warehouse once that data has been brought over. One thing to note as well is that we have an automatic schema migration feature here. So if we detect new schemas or tables or objects added to that schema, we'll automatically pick up them changes and replicate them over to your database as well. So your engineers don't need to worry about new schema changes and manage that in the warehouse as well. This is all done automatically by Fivetran. So I'm just going to save changes here. I'm going to click continue. That's just saying we need to resync our table because we've made some changes. I'll just show you the status page here, where you can see previous sync history. Coming soon to our UI, there's a log service as well, where you'll be able to view the logs for your sync in the dashboard here. And then this is our setup page, where you can see the connection details we previously entered. We can also select replication frequency, so I might just put these to 1 hour syncs. And then here's a delay notification. So if a sync hasn't happened for, let's say, 2 hours, maybe send an email alert to bring this to my attention. So I'm happy enough with all of them details. So what I'm going to do is I'm going to unpause the sync and let this run. And you can see here there's some user actions and alerts and stats. I'm just going to click back out to my connector and show you there that the sync is running. So that's how to add a MySQL database using Fivetran. One thing I wanted to run through as well is our brand new transformation layer. As Fivetran has shifted the ETL into ELT, where we were performing the extract and load, we now have a new transformation layer where you can perform your transformations directly in the warehouse. A lot of the transformations in the past were done pre-load, where customers, or sorry, business users were stripping out potentially important information and then loading their data into the warehouse. What Fivetran is proposing is that we load all of your data into your data warehouse so that all of that data is available for reporting and analysis. Most people might use transformations for calculating fields or formula fields, for splitting or merging values or tables, for data type standardization perhaps, maybe some key restructuring, or maybe summarization of data or aggregating data across schemas or data sets. So I have one or two small examples of transformations prepared here that I can show you. So what I'm going to do is click Add Transformation. I'm just going to give it a test name. So my webinar transform. I'm just going to pull some SQL I have written earlier on. Now this is a very simple transformation that's just going to create a table in my schema that searches at the payment table for values less than $4.99. I'm just going to paste this into my SQL text box. And you can select your schedule in which this transformation is going to run. So you can trigger it when new data becomes available in that table, or you can also select it to run on a specific schedule. So you can run it every 5 minutes, every 30 minutes, 1 hour. I'm just going to select to run when new data is available. We're also going to select what table we want to run this transformation against. So I'm going to select the payments table, as we're deriving a new table from that table. So I'm going to click Save and Run. This is a warning just to say that this code is actually going to be executed on your target warehouse. I'm going to click Run now, and it's going to perform the transformation in the warehouse. So that has ran successfully, and we can see here that it has succeeded. So I'm going to go back and view the transformation. And you can see a log here saying that it was successful. I'll just flick back to my database and show you where that table was created. I'll refresh my tree. So now you can see a small payment table in the warehouse with 12,000 rows. I have another quick transformation to show you where I'm just going to delete data in that table that has a value less than 2. So I'll click Add Transformation. We'll give it another name. And place the code into the SQL script box. So I'm just going to delete from that table where the amount is less than 2. I'm going to run again when new data is available. I'm going to select the table to run that against again. So I'll click Save and Run. Again, it's just warning me that this action will be performed in the warehouse. And we can see a success again, and rows affected 3,000. I'll just click back to the transformation homepage where you can see the logs again for each of the connector, or for each of the transformations. And you can see a success there. Now you can manually trigger these transformations. You can select Run Now, or you can disable. So let's say if I just run it again, there shouldn't be any rows there, so we'll probably have 0 rows affected. You can see it's just still running there. And it succeeded, 0 rows affected, as there were no more values left less than 2 in the amount. So that's pretty much it. That's adding a MySQL data warehouse, or sorry, adding a MySQL database as a connector in Fivetran, and also adding some simple transformations to perform some tasks in your warehouse post data load. So I'm just going to hand back over to Peter now so he can talk about Snowflake.
Oh, here we go. I should be online now. Barry, I'm going to ask you to forward those slides, because as you know, I don't have any control control over those slides. What I want to do is take about 10 minutes or so to give you a feel on what Snowflake is and what makes Snowflake come about. Actually, if we go one forward here, Barry, this basically tells where we come from, and it looked for a moment as if we came from nowhere, but now there is an image there. The company was founded in 2012, basically by a couple of engineers, actually 3 people, who left their current employer, a database vendor, because they said we want to be able to use all that functionality that you would expect in the cloud in a data warehousing or big data analytics environment. At the time, we already saw a lot of people taking their database and putting it in the cloud, which is really just bringing all the limitations and all the management overhead that you used to have on your own machine onto a different machine, which is basically the cloud vendor system. They said, no, the cloud brings you so many advantages that we want to make use of that. And because their current employer was not as cloud savvy as they could have been, they said, okay, well, in that case, we're going to start for ourselves. So they started building that data warehouse engine as a service, so to say. The product grew, the customers adopting to the product grew as well. So in 2015, the environment became general available. We started to structure an organization, operations, sales, and so on around it. Fast forward to today, there's more than 1,500 active customers. And if I ask my marketing team how many customers do we have, it's around 4,000. Basically because, like I said, it's software as a service. You can go to snowflake.com, you can get yourself an account, and from that point on, you are a customer of ours using the system. The 1,500 number, and I've been told it's approaching the 2,000 now, is about companies actually using this on a day-to-day basis as part of their business and the decisions they make for their business. So that's really that number, which also kind of implies that the range of customers actually using the product is really overwhelming, down from small-ish companies of maybe 10 to 20 people in staff, all the way up to companies like AT&T or Capital One in the United States. Nike is a very well-known customer of ours, who have thousands and thousands of users actually using this system. So if you could move forward one, this depicts what those engineers, those gentlemen, the founders of Snowflake had in mind when they joined after leaving their previous employer, and they said, okay, let's take a big whiteboard and think of what should the architecture look like, and if there's anything distinguishing Snowflake from other data warehouses that run in the cloud environment, the architecture is it. And they said, well, this needs to be a complete SQL database. Think 2012, at that point in time, when you talk analytics, when you talk big data, Hadoop was the best thing since sliced bread. And from a data collecting perspective, that's definitely the case. But what we found is that you need a whole bunch of specific expertise to actually make this work in an analytical environment. These gentlemen said, no, it needs to be an SQL database because everybody needs to be able to connect to it. And this has been the philosophy that we had for the last actually for forever, for as far as we can remember. As an example, we supply you with a very good SQL data warehouse engine. We rely on partners on our ecosystem like Fivetran to get the data in, and companies like Looker and Tableau and so on and so forth to actually visualize that data. We can only do that by speaking the generic language, the lingua franca that everybody understands, and that's SQL. I happen to know for a fact that in our engineering team, I sometimes call them religious fanatics that say, if it's not ANSI SQL 99, then I'm not going to support it. And that really makes us very interoperable with the outside world. As you saw just now, well, Barry was actually pulling in data, transforming data, loading data, all based on standard SQL. You didn't have to see anything from the underlying data engine. It's just a machine that does its work, and it lives happily in the background with front-end tools like Fivetran of this world. Which also alludes to the next bullet that we see here, which was, again, like I said, part of the architecture philosophy. You should not have to worry about it. Again, if you look at on-premise databases that go into the cloud, or if you look to Hadoop file systems that go into the cloud, you as an end user, you as a customer, as a business user, still have to do a lot of work to just make the system work before you can start implementing your use cases. This is all taken away by Snowflake. Snowflake says the platform is there, the data management environment is there. All you need to do is put your data in, use an intelligent tool like Fivetran to push your data into it, and then you can start analyze it. Don't worry about the management. As you can see, I'm the gray-haired guy. I remember that when we started to build a data warehouse, or we embarked on any data warehouse project, first thing we needed to do is to define and basically limit the amount of users that we're going to connect to it, the size of the data that we're going to put into it, and so on and so forth. Then we concise and scope the system, and then we can finally start to build and implement use cases. What we said with Snowflake is, no, it just needs to be there. It runs in the cloud. As a result of that, it's impossible to say, oh, I'm going to download me some Snowflake and run it on my laptop. No, it only runs in the cloud. It runs on AWS, Azure, and soon on the Google Cloud Platform. So the management part, all the overhead of that goes away. The third one, like I said, this was 2012. Everybody was talking about Hadoop. Everybody was talking about unstructured or semi-structured data. But when you think of data warehousing, you see rows and columns, and everything is predefined. What these gentlemen did is they said, well, what we are going to do is we're going to almost reinvent the data warehouse, combine the strength of the unstructured world, the semi-structured world, and then I'm thinking about things like JSON data, like XML data, like document structures and so on. Hadoop likes Parquet data, for example, these kind of things, where you don't know the structure of the data beforehand. You'll be able to load it anyway into what Snowflake calls variant data, and that will just be part of the data warehouse, which basically means that it will be very easy for the end user, for the business user, to say, okay, now I'm going to correlate my point of sale data with what people are saying about me on social media. Oh, and I'm going to throw in weather information into that mix as well, to basically look for correlations and look for unexpected connections between the data. And now it's really about the data telling me what I should be looking for, as opposed to vice versa, me thinking out all the questions beforehand and then start asking those questions, expecting specific answers. So it's an all of your data perspective. And on top of that, like I said earlier, it's an SQL database. So we want to be able to connect all of our users as well. I always like to extend that. I would like to extend and to say, well, it has to be all of your users, basically from the financial analyst running Excel spreadsheets, all the way up to the data scientist running his Python and R scripts at the back end, but also having that data always available to you on a 24/7 basis. And that's really the key to why Snowflake had to be reinvented from the ground up for the cloud, if you think about it, because the data needed to be there. The data needs to be readily available. You should not be worried about how many people are using the system. You should not be worried about, oh, are Are there changes going on in the data that I need to, so the system will be down for whatever reason, which you very often see when you need to scale systems up and so on. You don't want to be hampered by that. It's going to be all of your users all of the time. And then the one that everybody always says that they want, and which is very often the biggest reason for people to actually move to the cloud, is if you're not using it, you don't want to pay for it. And the interesting thing is each and every one of databases that we see running in the cloud nowadays are always consuming resources. Therefore, you're always paying for it. Even when you just went home, had your dinner and went to bed, the system is still there, the system is still running, it's still consuming resources, and you're still paying for what you're not using. With Snowflake, we are saying, well, if you're not using any resources, you won't be paying for anything. Like you saw just now in Barry's demo, when he was pushing the SQL into Snowflake, because you want to do ELT type of transformations, then at that point in time, you'll be processing data, and that will cost some processing power and therefore some resources. Once that transformation is done, you're not using any resources anymore, and you won't be paying for that. And the last one is of course the live data sharing, because if you have that dynamic allocation of those resources, then it's going to be very easy to say, well, you know what? Here's my data. Here are my my access roles. Anyone with the right access roles can connect to any kind of data, because the resources are elastically available to you, and you'll be able to query that dynamically and get access to the data just like it was your own database. So if we can move forward, just a very quick look into what makes the architecture of Snowflake different from your typical database. The key thing, what's important to us and our engineering team is the separation, the only loosely coupling of storage to compute. So the storage of the data is going to be always, well, from our perspective, the cheapest way that we can find, which on AWS is S3, which on Azure is blob storage. That's where the data lives, and we run compute engines on top of that data, and they're depicted here in this image as cogwheels, as you can see. So, for example, your data scientist would run in a specific what we call virtual warehouse, a compute instance, and if he needs more processing power, he can just opt to actually up that processing power and run that run his comprehensive algorithm in more processing power. At that point in time, the user will choose to apply more resources to it. On the back end, you can see, for example, a data pipeline coming in, pushing data in. If you think about the classic ETL processing, then a lot of transformation would happen outside the system, of course, with all the limitations of the scaling that we have there. When you look at the modern way of implementing these type of processes, like you just saw in Barry's demonstration, you'll be pushing SQL into the target engine, in this case Snowflake, and again, by upping the resources that are available to you, because they're elastically available, you could go ahead and say, well, I'm going to scale up for this specific transformation functionality, therefore running that transformation function much faster. So that will not only always make your batch window large enough, but always also it'll allow you to have a much higher frequency of data refresh, because the processing will be so much faster as well. And the last one is the one that's typically at the front end, where you would implement maximum concurrency. Like I said earlier, all of your users, all of the time, having processing power available to you on an as required or an on-demand basis, basically allows you to have maximum concurrency. We now see customers running about 5,500 to 6,000 concurrent queries on their Snowflake database on a regular basis. And that's because, well, because the data brings value, therefore they would need their data available to them instantly. This is done by what we call virtual warehouses. Everybody's running on the same storage, everybody's using the same one single source of the truth, so to say, and they have all the data available to them using flexible compute resources. So if you could move forward one. Oh, we lost Barry. Barry, if you could move forward one slide. Oh, here we go. So leveraging the data in Snowflake is really about, so how is how are customers using this applications nowadays? These are 4 different use cases, as you can see, in 3 different pillars. The one that's the most common is the first one, where you see many different silos. So if you could move forward one, Barry. Where you have different silos, integrating different silos, having all the data in one place, and that one place being the cloud. Like I said, I'm the gray-haired guy, and I've been promising this for decades now, and I would say that the cloud is really finally making this come true. The second use case is really modernizing data warehouses, taking on-prem systems. So if you could move forward one, Barry. Taking the on-prem systems into the cloud. As an example, Capital One is a big bank in the United States, and they just had a party because they switched off the last of 4 Teradata appliances, replaced them all by Snowflake, having the entire data warehouse and data platform in the cloud. But it's also another way of modernizing, and that's taking on-premise databases to the cloud and modernizing those. For a while, we've been doing almost the half of our business in replacing Redshift, for example, on AWS, because, well, very rapidly people start using these systems. As long as it's limited environments, then everything is fine. But when you need to scale up, scale out, then you need something that will scale with you, and that's Snowflake. The third one and the last, or the fourth one, I should say, the last one is really, like I mentioned, the variant functionality. Where the semi-structured data is integrated into the data warehouse, and all the data would be readily available to it. It supports about 80 to maybe even 90% of the of what nowadays is Hadoop use cases and data lakes. That's really at the very high level what I wanted to explain about Snowflake, what we are all about, where do we come from, and if you have any questions, I think on the next slide there's an email address. By all means, go ahead and dig in. And if you have any questions, you could post those into the chat box here as well.
Perfect. Thanks a million, Peter, and thank you, Barry. Really insightful, interesting presentations. We do actually have a few questions, so we're almost out of time, but we're going to run through a few of them. First question, Barry, I think it's for you. For Fivetran, what kinds of data do you bring in, structured and unstructured data? I think you're on mute there, Barry.
Thanks, Fionn. Sorry about that.
No.
Yeah, so a lot of the data we bring over are database sources and cloud applications. So for databases, it would obviously be structured data, but we do have a MongoDB connector, so we can sync from there. And also a lot of the API connectors that we have, we receive the data in JSON format. So we do a bit of processing on that to strip out the data types and deduplicate the data and slightly normalize it before we push it into a ready to query schema. So we can handle both structured and unstructured data, yeah.
Great, thank you, Barry. And this is another one for you, actually. What method does Fivetran use to replicate databases?
So for replicating databases, when we connect to your source, we essentially do a historical sync first. So we basically read from every table, we pull all the historical data, and then push that data to your Snowflake warehouse in an upsert fashion. So we'll basically insert the records if they don't exist, or we'll update the records if they do exist.
Perfect, thanks a million. And we just have another couple coming in here. How can I encrypt data in Snowflake? I think, Peter, that's probably going to be for you.
I'm going to go and try and answer that one. Answer is yes, you can encrypt data in Snowflake, and in fact, I would want to say the beauty of the case is that Snowflake doesn't know any unencrypted data. So data is always encrypted by keys that are rotated regularly within Snowflake. What you can do as a business user is you can add your own keys for very specific, for example, privacy sensitive information. So data within Snowflake, it's always encrypted in transit and at rest, very similar to Fivetran, but the customer could add its own encryption keys as well.
Perfect, thank you, Peter. And another one for you is how is Snowflake licensing?
It's not, like I said, it's a software as a service. So basically, as I was just explaining, you see some compute, you see some storage. The storage is just, well, it's data from the cloud provider. So when AWS says, I'm going to charge you $20 for this terabyte of data, then we charge those $20 to our end customer. What you pay us for is actually the seconds that you actually run the compute. So when Fivetran throws a SQL command to us to transform the data, the seconds that are required to run that transformation are in fact charged to the owner of that to the owner of the data and the system, and that's it. Perfect.
Thank you, Peter. And another one for Barry here. Can Fivetran integrations be set up by configuration script instead of UI? I think you're on mute again there, Barry.
Sorry, thanks, Fionn. Yes, well, we're just about to release our API layer. It's available for beta at the moment. So you can script up the connector management. You can create connectors using a script hitting up our API.
Perfect, thank you, Barry. And then one last one for Snowflake. How do I manage the data? Is it files? Oops, Peter, can you mute?
Yeah, very similar to my previous question, you don't. Like I said, Snowflake itself, it's a software as a service. So when you ingest data, like you just saw in Barry's demo, it's ingested into a database, and the data then gets stored by Snowflake in Snowflake managed buckets. So it's not that you have to manage your data. It's not that you have to supply the space to actually put the data in. All that is managed by the Snowflake service.
Perfect. Thank you very much, Peter. Thank you, Barry. I think we're all out of time, so we will leave it there. So yeah, thanks very much for a very insightful presentation and for answering the questions as well. And thank you for our audience for joining us this afternoon. Again, if you have any further questions, you can always email us. You can see the emails there. Or if you do want to go forward with a free trial or a POC, we can do these together, both Snowflake with Fivetran. So yeah, thank you everyone, and have a great day.
Thanks.
Thank you. Bye.
Bye-bye.